Hello everyone and welcome to the video solution of the Unit 6 homework assignment, What's the Weather Like? Whether financial, political, or social, data's true power lies in its ability to answer questions definitively. So let's take what you've learned about Python requests, APIs, and JSON traversals to answer a fundamental question. What's the weather like as we approach the equator? Now, we know what you may be thinking. It gets hotter, but if pressed, how would you prove it? In this example, you'll be creating a Python script to visualize the weather of 500 plus cities across the world of varying distance from the equator. To accomplish this, you'll be utilizing a simple Python library, requests, the Open Weather Map API, and a little common sense to create a representative model of weather across world cities. The objective is to build a series of scatter plots to showcase the following relationships: temperature versus latitude, humidity versus latitude, cloudiness versus latitude, and wind speed versus latitude. The final notebook must randomly select at least 500 unique cities based on latitude and longitude, perform a weather check on each of the cities using a series of successive API calls, include a print log of each city as it's being processed with the city number, city name, and requested URL, save both the CSV of all data retrieved and PNG files for each of the scatterplots. So we want to use the Matplotlib and Seaborn libraries for our scatterplots, and each of the plots should be properly labeled with titles and axes labeled. Let's open up Jupyter Notebook. The first thing I'm going to do is import my dependencies. Okay, so we have quite a few dependencies. Let's go through them and see why we need each one. Matplotlib allows us to plot our scatter plots of the four scatter plots that we need. Pandas allows us to take the data frame that we're going to build with all of our data and export it and work with it further. NumPy we need to get a random list of numbers for our latitudes and longitudes. Seaborn is to make our scatter plot look pretty. Requests is to be able to get our data from Open Weather Map. Use time to get the current date for our plot titles. URLlib is to help us build our query URL. And last but not least, CityPy allows us to get the city name closest to a lat-long pair. Next up, I'm going to create an output file. So this is just to specify our output folder and the file name that we want. We'll be working with this later. When we have all of our data, we'll be exporting the data frame into the CSV. All right, let's get started on generating our cities list. First thing I'm going to do is create two lists for holding the latitude-longitude pairs and our cities. Next up, I'm going to create a set of random latitude and longitude combinations and then zip them together. Here we're using our NumPy library, and we're getting random uniform numbers from -90 to 90 for our latitudes and -180 to 180 for our longitudes. And we're getting 1500 because we want to make sure that we have at least 500 cities for when we plot our graphs. And for sure there are going to be repeats, so by doing 1500 we'll guarantee at least 500 cities. And then we zip them together to allow us to easily loop through them to find the city names, which is what we're going to do next. Okay, so here what we've done is we've looped through our lat-longs list, and we take each latitude-longitude pair and we use CityPy to figure out what the nearest city is to that latitude-longitude pair, and then we store the city name. Then we check if that city is not already in our cities list that we created earlier, we add it. And here we go, we're just checking the length of the cities to see how many unique cities we ended up getting, which is 635. Next up, we're going to start performing the API calls. First thing I'm going to do here is store my API key and create the starting URL. So here we have our API key, which you'll get from signing up for an account, and you'll want to change the API key here when you're doing your own homework. And here we have our starting URL. This is the base URL that will be given with the documentation from Open Weather Map. And we do units imperial because we want our weather to be in Fahrenheit. And then we have the add because we had more parameters. And this is the parameter for our API key, which we've added right here. So our URL, if we print it, will look like this right now. And we're not going to get a result if we click on this link because we haven't specified a city yet. So there you go, see? Nothing to geocode. Up next, I'm going to create an empty list for the city data. This list is just to allow us to store all of the data that we get from our API calls. Remember from the instructions, it says that we want to print a log of each city as it's being processed. So what I'm going to do next is start that logger. So I'm not going to run this all yet because I want to make sure that we have our API calls getting pulled and everything before we start printing to the logger. Next up, I'm going to create some counters. These are to help us track how many calls we've done. Next up, I'm going to start the loop through our cities list. Here what we're doing is we are looping through our cities list, but we're using enumerate because it allows us to loop over something and have an automatic counter. So we can just work with I as a counter and city as the value. Next up, I'm going to group cities in sets of 50 for logging purposes. Every 50 cities, as long as I is also greater than or equal to 50, I'm going to, so this is after the first set, I'm going to add 1 to the set count, and I'm going to reset our record count to 0. Next up, I'm going to create the endpoint URL with each city. Alright, so here we are adding to the URL that we built earlier up there, and we are adding our final parameter, which is the city name. Next up, I'm going to log the URL, record, and set numbers. I'm just printing out processing record count of set count, and then the city name. And the reason I can do this without concatenating is because I have this F in the front. It allows us to format, and then we just put the values that we want in curly braces, and Python does the formatting automatically for us, and then we'll print the URL. Next up, I'm just going to add 1 to the record count. And now finally, I'm going to run the API requests for each of the cities. Here, we are just doing our normal GET request on our city URL, and we're storing a JSON version of the data into city weather. Next up, I'm going to parse out the maximum temperature, humidity, and cloudiness. So here what we're doing is we are grabbing our latitude, longitude, maximum temperature, humidity, cloudiness, wind speed, the country, and the current date. Next up, I'm going to append this city information into city data list. Here we are just appending the information in the form of a dictionary to the list that we created right up here. Next up, I'm going to finish out the try and accept. Okay, so what we have here is the last bit of our code. It's called a try and accept. So what'll happen is Python will try every single thing in this block. If even one thing doesn't work out, it's going to go to the accept clause and do what we have here. So which is print city not found, skipping. Sometimes the cities that we get from WeatherPy won't have data in OpenWeatherMap. So when we try to grab the data here for a city that doesn't exist in OpenWeatherMap, it's going to throw an error and stop our code. By wrapping everything in a try and accept, it allows us to continue with our code. Last bit, I'm going to indicate that the data retrieval is complete. Now, don't worry if this takes some time. There's 635 cities to run through. Alright, once you have run through all of your cities, you'll have an output that looks something like this. Next up, I'm going to convert the array of JSONs into a pandas data frame. We have our city, our cloudiness, country, date, humidity, latitude, longitude, maximum temperature, and wind speed. Now remember, if you don't specify the column order, pandas will automatically sort it into alphabetical order. Next up, I'm going to extract relevant fields from the data frame. Here we're just grabbing the columns that we want for the scatter plots that we're going to be creating. Next up, I'm going to export the city data into the CSV. Here we are taking our city data frame and we're converting it to a CSV to the output data file that we specified earlier, and we are changing the index label to city ID instead of just having it blank. Last but not least, before we get to our scatter plots, I'm going to show the record count to see how many cities we actually ended up with. So we ended up with 567 cities. Let's move on to plotting latitude versus temperature. So the first thing I'm going to do is build the scatter plot. Okay, so here we're just using plot.scatter. Our x values are our latitudes, and our y values are our temperature. And we just have our markers as circles, and the edge color is black. And we're just making it not completely opaque. Next up, I'm going to incorporate the other graph properties. So we are adding a title of city latitude versus maximum temperature, and with today's date in parentheses. Our x label is latitude, our y label is max temperature, and we're just adding a grid to our plot. Next up, I'm going to save the figure and then display the plot. And there we have it, our maximum temperatures versus our latitude. Next up, we're going to do something very similar for our latitude versus humidity plot. So this looks very similar. The only differences are that we change our Y values to our humidity list, and we adjust the titles and the labels accordingly, and the figure name. Okay, we don't want to overwrite our previous figure 1. And there we have our city latitude versus humidity. Next up is something very similar for our latitude versus cloudiness. Okay, and there we have our latitude versus cloudiness plot. Last but not least, we have our latitude versus wind speed plot. And that is the final graph for this homework exercise. Let's take a look at our output folder. Okay, we have our city CSV, and there we go. We have our city ID, our city name, cloudiness, the country, date, humidity, latitude, longitude, maximum temperature, and wind speed. Take a look at each of the figures. Figure 1, we have our city latitude versus maximum temperature. Figure 2, our city latitude versus humidity. Figure 3, our city latitude versus cloudiness. And figure 4, our city latitude versus wind speed. And that is the video solution to WeatherPy.